we are preparing for our Unit 8 test. Tomorrow will be the practice test. On Wednesday, it will be the real test. So today we're going to review. It's only 4 objectives long. So this is a really short unit that we have. So we're going to review the first objectives because it's been a while since we talked about ratios. For it only being 4 objectives long, it's kind of taking us a while to get through it. So let's look at that. First unit objective is CO46. I can write and compare ratios. So remember that a ratio is a comparison of 2 numbers using division. Remember our ratios, we could write the 3 different ways. We could write it by saying 18 to 13. We could write it by saying 18 over 13 or 18 with our colon 13. They're all 18 to 13. So in the example here, that was wins to losses, wins over losses, wins to losses. So each of those 3 ways is all showing a ratio. Devices are closed up. We talked about equivalent ratios, the ones that have the same value. So if we put it as our fraction, remember that fraction bar means divide. So if we want to know if it has the same value, we're going to take our top number, our numerator, and divide it by the denominator. So if we were looking at 15 twelfths and 25 20ths, and we want to know if they are equivalent, we would take the top, divide it by the bottom. 15 divided by 12. 15 divided by 12 gives us, oh my goodness, 1, oh my goodness, this is not wanting to work for me, of course. So 1.25. 15 divided by 12 is 1.25. If we do 25 divided by 20, we get 1.25. So they are equivalent fractions because when we divide the numerator by the denominator, we got the same number. So they are equivalent, they equal each other. Let's see what kind of work we had to do for our ratios. Writing ratios in the simplest form, just like simplifying our fractions. What can I divide out of both sides? What is the biggest common factor I can divide out? So to simplify our fraction, you would just divide it down. Comparing ratios. So remember when we were comparing, it's still CO46, yes. So when we were comparing our ratios, when we compared Louie's rock to pop to Anna's rock to pop ratios, Louie would be 9 over 24, Anna was 28 over 70. So we would want to compare who had the higher ratio of rock to pop. How do we want to compare those? What do we need to do? Landon? We have to divide. 9 divided by 24, 28 divided by 70, and find out which one is the higher number. They have the higher ratio. So remember when we're comparing, we're turning them into those fractions. That fraction bar means we're going to divide. Remember doing that a little bit? Any questions on those ratios? Okay, we're feeling pretty good about that. Landon, were you feeling good about that? You're making a little look there.
Yeah, I think I have.
So if we looked here at our question, who has the greater ratio of pop CDs to hip hop CDs? How would I set that up? Landon? So Lewis had 24/16, pop to hip hop. Anna has 70/40. So what would Lewis's ratio be? What is 24 divided by 16? Zoe, is that your hand up?
Oh no, sorry.
Okay. Landon?
1.5.
1.5. What is Anna's? 70/40.
1.75.
1.75. So who has the greater ratio of pop CDs to hip hop CDs? Anna does, because that 1.75 is bigger. So when we're comparing those two ratios, you have to do that dividing to see what it is.
Some of that.
Peyton, what are you saying?
She said she lost her calculator.
Oh. All right. So feeling a little better about CO46? Let's look at CO47. I can write and compare rates. What's the big difference between a ratio and a rate? What do we want to do with our rates, Landon? So we're on CO47 now. Remember, with those rates, we want to find that unit rate. So that unit rate means we get a denominator down to 1 unit. So our rate is two quantities measured in different units. So when you're driving your car, it could be miles per hour. How fast is our car going? How many miles can it go in an hour? When we find that unit rate, that's when we always want to get that bottom number down to a 1. So finding our unit rate. If we know it can grow 6 inches in 12 hours, what do I have to do to find my unit rate?
6
Say it again, Peyton.
6 divided by 12.
Why are we dividing by 12?
Because it's trying to find out how many you're going.
Because we have 12 hours on the bottom. And what do we want on the bottom, Peyton?
Oh, like you're trying to find how much.
We want it to go down to 1 hour.
Okay, yeah, I'm just trying to like.
Yep, that's why we're walking through it to help us remember why. Why did we divide by 12? Because 12 divided by 12 gives us our 1 hour. And whatever we do to the denominator, we do to our numerator. So is it that we're always going to divide by 12?
No, you're just dividing by what.
You always divide by the denominator. So whatever your denominator is, that's what you divide by, so you end up with a 1 on the bottom. So 6 divided by 12 gave us 0.5, so it can grow 0.5 inches in 1 hour. So when we're finding that unit rate, we're dividing it down to a 1 on the bottom. Whatever you divide the bottom by, you divide the top by. So it's not that we're always dividing by 12. It's that we're always going to divide by the denominator. Oops. So comparing unit rates, remember we were comparing our bulk pasta for buying it at Costco versus buying just a box at Target. Which one is a better deal?
The Costco. Target's the best. It's a Costco.
A lot of times it's Costco. It's not always. That's how Costco makes its money. You go in there to buy the bargain deals, and then you're like, well, I'm already here. I'm going to buy this, this, and this, and it's not a better deal. But since you're already shopping there, you just buy it anyways. So You never know, just because it's buying in bulk doesn't mean it's a better deal. So if we're gonna look at our 10 pounds of bulk pasta for $15, what if I say, how much pasta can I buy for $1? How would I set that up? If I want to see what's the better deal, if it's 10 pounds of pasta for $15 and I want to know how much pasta I could buy for $1, how would I solve that? Will?
Yeah, we're starting off as a fraction. So
Yep.
10 over 15.
So it would be 10 pounds. Now, I caught a lot of us when we were doing our work problems in the workbook, we weren't putting our measurements on there. And that's how we were ending up with mistakes. So if I put $15 on the bottom, what has to be on the bottom for the other side to compare it? We're going to have to put dollars on the bottom for the other side, right? 3.98. And that was for 2 pounds. So whatever I put on the bottom for one side, when we're comparing, we want to compare the same things. So if I put money on the bottom for one side, I have to put money on the bottom for the other side. So how am I going to compare those? 10 pounds for $15 or 2 pounds for $3.98. What do I have to do, Kira?
You have to do 10 divided by 15 for the first one.
Why would I do, if I want to know how much I buy for $1, am I going to do 10 divided by 15? So I want to do the unit rate. I want to compare which one has a better unit rate. Which one can I get more for my $1? So I'm walking us through a little bit differently than how we did it. We did it reverse when we worked the problem out. And then when we went to our workbook page, we said, oh, we should put the dollar on the bottom. So this time I'm having us put the dollar on the bottom. So if I want it to be $1 on the bottom,
You divide 15.
I'm going to divide by 15.
Oh, see,
So
that
what
makes
is
a lot
10
more
divided by 15? Peyton, you got a calculator out. What's 10 divided by 15?
sense. 0.6 something. I just lost it.
So we'll say 0.6 pounds. For $1, I can get 0.6 pounds. But if I am buying the package at Target, how much can I get for my $1? What do I have to divide by?
15.
No, this time I have to divide by 3.98. So what's 2 pounds divided by 3.98, Tristan?
0.5. 0.50.
0.5 pounds. Which one is a better deal? Which one can I get more for my $1?
Costco,
I can get more for my dollar from Costco. So the pasta is a better deal at Costco. Okay? So to compare our rates, you want to make sure that you have the same thing on the bottom. What we did when we did our objective page before, we put the $15 on top for 10 pounds, right? And we found how much 1 pound would be. You're still going to get the same answer. You're still going to find that Costco was a better deal. But when we're comparing those unit rates, you have to look at what it's asking. So it says find the unit price for both types. So I found what's my unit price, which one can I get, how much pounds can I get for $1? Or you could say 1 pound would be how much of a price. Either way, you're going to find that Costco is a better deal. Does that make sense? Any questions? The most important thing to remember is if you have dollars on the bottom, you keep dollars on the bottom. You can't have dollars on the bottom for one rate and dollars on the top for your other rate. They have to be the same. It's important that you put your measurements when you're doing your rate. That way you know that you're being consistent, that your dollars are on the bottom, dollars are on the bottom. Be consistent. All right, CO48. I can write and solve proportions using equivalent fractions. So a proportion is an equation stating that the two ratios are equivalent. So we could say 3/5 is equal to 6/10. Sometimes it's easy like this one. We could say, well, if I multiply both the top and the bottom by 2, 3/5 turns into 6/10. They're equivalent. Got it. It's not always that easy. It's not always I can just multiply the top and the bottom to get that. Doesn't have to be the case to be equivalent. So how do we find those equivalent fractions when it's not something easy? When it's 6/10 equals what over 25? It's not easy to go from 10 to 25. Uh-oh. I'm not just going to multiply by 2 and say 5 times 2 is 10, 3 times 2 is 6. Now I have to do math. What math do I do here? How do I solve for my x? Who remembers what we do?
You do 6 divided by 10.
No.
You do 6 divided by 25.
We got some guessing going on. What do you think, Will?
You multiply by 25 to get exponent solved, and then you multiply 25 by 6, then divide by 2.
Did I get it right?
So we have, I'm just writing it bigger over here. 6/10 equals x over 25. So what Will said is it's 2 steps. The first step is you multiply by 25 because that's going to get our x by itself. So 6 times 25 is what? What is it? 150 over 10. Now we're going to divide because we have that fraction bar. 150 divided by 10 gives us 15. So we know x equals 15. So remember, when we're finding those equivalent fractions, we are doing those 2 steps. You're multiplying. It's multiplying that 6 and 25. So that way 25 crosses off, and then we have 6 times 25. Then we divide it by the 10. So you can set the proportion up in several ways. We were talking about that with the rate. You have to be consistent. So this is where it really is important. So what it was, Peyton? It was 6/10 equals x over 25. So your first step was multiply by 25. And then you divided by 10. So when we are setting up our proportions, you have to make sure your measurements are consistent. So if we look up let's look down here. Setting up a proportion may be set up several ways. We say yesterday we bought 8 folders for $4. Today you buy 5 more folders. How much will 5 folders cost? So our money, our dollars, is on top. Our folders is on the bottom. So over here, our dollars is on top. Our folders is on the bottom. So if you put dollars on top, you have to keep dollars on top for both of them. folders on the bottom for both of them.
Okay, so let me see if I can get this.
So for this one,
Oh,
if 8 folders cost $4, how much do 5 folders cost? How do we solve that,
okay, so
right?
um,
We're doing the same kind of math. So what's our first step going to be?
yes.
What was our first step?
Oh my bad. You had times.
By what?
Times it by 25.
Well, we're doing 4/8 x over 5. Yep.
So we're doing the one with the 8 and 5.
4/8 equals x over 5.
So you would do 8 times 5.
Yeah, we're gonna, not 8, we're gonna multiply both sides by 5. So this way, our 5's cancel out and we get x by itself. But you see here, we have 5 times 4.
And then that would that equals 20.
And then you divide that by the 8. So what is 20 divided by 8, Peyton?
2.5.
So x equals 2.5. So it's those 2 steps. You multiply, so you get the x by itself, and then you divide. Okay? Does that make sense? Most important thing is remembering, if we have our cost on top, the cost needs to stay on top for both of them. Folders on the bottom for both of them. Any questions about CO48? We're feeling pretty good about that? Let's see, writing and solving a proportion. So let's work this one out together. The elevators in the Empire State Building can pass 80 floors in 45 seconds. Follow the steps to find the number of floors that the elevator can pass in 9 seconds. So write a proportion where x represents the number of floors passed in 9 seconds. How would I set this up? Tristan C. How would I set up my proportion? The elevators in the Empire State Building can pass 80 floors in 45 seconds. We are on CO48. Oops. I didn't move on to the next one. We're still on CO48. So how am I going to set this up, Tristan?
I'm thinking that it is 80 over 45.
So 80 floors. Remember, I want to put my labels in 45 seconds. So that's, what is the other part of the proportion? What else do I have to put, Tristan?
X over 9.
So we want to know how many floors, because our question is the number of floors. So x floors over 9 seconds. So we want to make sure that we have floors to floors on the top, seconds to seconds on the bottom. What's my first step in solving this, Nick?
The first step in solving this is you have to do 80. So you have to do. Okay, so you have to cross out the 9, because then you have to do 80 times 9.
So I'm going to multiply both sides by that 9. So 9 divided by 9, multiply 9 divided by 9 gives me my 1. So I'm left with x floors. And then I have 9 times 80, which is 720 over 45. So 720 floors, 45 seconds.
That's our answer?
Nope.
Oh, then we have to divide it.
I need to find x floors. So what do I have to do, Nick?
You have to do 720 divided by 45.
Yep, because I have this division bar right here.
16.
What is it, 16?
Yep.
So that gives me 16 floors is my x. I can go 16 floors in 9 seconds. It is fast. Those elevators, they're whipping it up and down real fast. 16 floors in 9 seconds. So, same math that we've been doing, now we just have our words put to it. But you're setting it up the same way. Make sense? All right, let's look at our last objective. CO49. I can write and solve proportions using cross products. So remember, the cross products is where we can multiply across or diagonally. 3 times 20 is 60. 4 times 15 is 60. It's a proportion. So using the cross products it's the same thing that we just did. We're just putting new words to it. You're still multiplying and dividing the same way. So let's try solving this. Writing and solving a proportion. Find the weight W of a 60-pound dog on the moon if a 105-pound person weighs 17.5 pounds on the moon. How am I going to set this up, Gabby? What are my two ratios? So, 60-pound dog, we want to know its weight on the moon. We know there's a 105-pound person that weighs 17.5 on the moon.
Okay, so
Shh. Oh, Gabby's going still. So the 105-pound person divided by 17.5 pounds on the moon. So then we have our 60-pound dog. This is the man or person. And we want to know X pounds on the moon. So I'm going to tell you, this gives us the X on the bottom, which makes it a little bit more complicated to work with. So it would be easier if we flip it and we say X pounds on the moon, because we want that one on top over the 60-pound dog. But that means we have to flip this one. So 17.5 pounds on the moon over 105-pound person. So now my X is already on the top. So when I set up my problem, I want to set it up with that X on the top. I can flip them, no problem. It just makes it easier to solve it. So I can flip it so my X is on top. Now I'm going to do the two-step problem that I've been doing. I want to get X by itself. So if I'm dividing by 60, I want to multiply by 60. So those cross off and we get X by itself. What is 60 times 17.5?
what?
Ryan?
1,050.
1,050. Then we want to divide that by our 105-pound person, which is what?
I did
10. So our dog on the moon would equal 10 pounds.
I did
Peyton,
5
do you
equations.
understand?
I did 5 equations. And
Well-
the first one, which was the least likely to be right, was that one. And then I got the answer. And so I erased all my work.
So do you understand
Yes.
the right way to do it?
Yes.
And that's why we do the work, so we can start understanding it. So tomorrow on the test, we can do well.
How's the test?
Tomorrow's the practice test,
Oh.
real test on Wednesday. So,
I have a question.
yes,
So X would equal 10 over.
yes. So X equals 10 pounds, because our question is, Find the weight of the 60-pound dog on the moon. So its weight on the moon is 10 pounds. So that's our answer. So now let's look at our next one. And let's see if we can set this one up correctly. There are 50 penguins at an aquarium. The ratio of rockhopper penguins to African penguins is 3:7. How many are rockhoppers? This was a little bit more complicated of a one for us to set up. Anybody remember how we set this one up? There are 50 penguins altogether. For every 3 rockhoppers, there are 7 African penguins. So, Scarlett, do you remember what to do? Put your hand down. Okay. So if there are 3 rockhoppers for every 7 African penguins, there are 3 rockhoppers for how many penguins altogether? 10, right? So for every 10 penguins, 3 of them would be rockhoppers. So 3 rockhoppers for 10 penguins. How many rockhoppers are there for 50 penguins? See how I set that up?
So let me see here.
How do I solve this then, Peyton?
So I do like divide it, like just like.
Same steps I've been doing. What's my first step? I want to solve for my rockhoppers.
So you do 3 times 50.
So I'm going to multiply it by 50 both sides.
It's 150.
150
Then you
over
do
10.
Then you do 150 over 10.
Yep.
You divide that. And then
So because it's a fraction bar, I need to divide. So 150 divided by 10 gives me what, Peyton?
15.
15. So there are 15 rockhoppers for 50 penguins.
I think I struggle a little bit on that one.
I don't think they're going to be quite this complicated on the test. But we do need to understand how to find that missing part of our proportion. Okay, so there are just the 4 objectives. You do need to make sure you remember how to do it. We were basically doing the same steps for the last 3 objectives, right? You're saying you had to multiply and then divide, but you have to make sure that you set them up consistently. I put rockhoppers on top, total penguins on bottom, total penguins on bottom. You have to make sure you're consistent with your measurements, with your labels, okay? So with that, we're going to say goodbye to our friends at home. We hope you are well. We will be doing our Unit 8 practice test tomorrow, real test on Wednesday. And we hope we are all prepared. Have a wonderful day.